Hello guys, welcome to my YouTube channel, The Wizard of Science. I am Bharat Kumaru, pursuing computer science and engineering degree in JNTU Anantapura. So, this is my first video of YouTube. So, I just want to discuss about the binary search trees. In that, we are going to discuss about the traversal and insertion techniques. It is a very important topic in the data structures. So, let's get started. See what is binary search trees. Binary search trees are also an binary tree, but the difference between the binary tree and the binary search trees are binary trees having the two chains which are having the random values. But in binary search trees, they follow a technique or the logic that is, let's see with this an example. If it is a root node, the left subtree must be having always the smaller value and the right subtree must be having always the larger value. If we see this example 29, the left subtree is smaller than that and right subtree is larger than that. This is the only logic we are following in the binary search trees for entire topic. Let's see with this an example. Here, root node is 21 and left subtree is 22 and right subtree is 28. What we have discussed earlier, in binary search trees, the left one should be the smaller one and the right one should be the larger value. So here, the left one is larger value. So it is not satisfying the binary search tree condition. And the right one is satisfying the condition, but it is not a binary search tree, it is a binary tree. Let's see with this an example. Here, root node is 21. So what the binary search tree condition? The left one should be the smaller value and the right one should be the larger value. Yes, it is satisfying. Left one is a smaller value and the right one is the larger value. Here, if we see this parent element, these two childs are this. Here, left subtree is 27 and right subtree is 39. So what we have discussed in binary search tree is left one should be the smaller, right? Yes, it is small. Right one should be the larger. Yes, it is right. Larger. So it is satisfying the condition perfectly. So it is a binary search tree. Perfect. Next, here 21 is the root node. So left one should be the smaller value and right one should be, it is satisfying the equation. And left one should be the smaller and the right one should be the larger. It is also satisfying. And here it is left one is smaller, but right one is also smaller. So it is not satisfying the condition. It is not a binary search tree. It is a just binary tree. Perfect. Let's see how we can create a binary search tree using these elements. So we have discussed what is basic rule of the binary search trees is we are having the parent node and the left one should be the smaller value and the right one should be the larger value. This is the only the basic concept we have to remember. So if we take this example, we have keep this root node as 45 here, and next 39 is smaller than 45, so it must be go left, and 56 is larger value, it go right. Like that we will construct a binary tree, but it is kind of messy, right? So let's see with the cool examples. Okay guys, let's create binary search tree from the scratch. So let's consider 50 as a root node. So second value is 30. So 30 is smaller than 50. So it goes towards left. And 60 is greater than 50. So it goes towards right. So next value is 38. 38, we will compare it from the root node. So if we compare with it 50, so 38 is smaller than 50. And if we compare with 30, it is greater than 30. So it will go towards right in the 30th node. Then the 35. We'll compare with the 50, it is smaller than that. So it will go left. It is greater than 30, it will go right. And it is smaller than 38, so it will go left. So next value, 55. 55 is greater than 50 and smaller than 60. So it will go towards left. So 22. 22 is smaller than 50 and smaller than 32. So it will go towards left. 59. 59 is greater than 50 and smaller than 60. So it will go left, and it is greater than 55. So it will go towards right. The next value is 94. So 94 is much bigger value. So it will go towards right first, and then it is also bigger than 60. It will go right. Okay. Next, the 13. 13 is the least value. So it will go left, and it is also smaller than 30. It will go left. It is also smaller than 22. It will all the way towards the left. So 98 is the biggest value among all these, so it will automatically goes towards light. We can check either. So it is 50, 98 is greater than 50, and it is greater than 62, and it is greater than 94. So it will towards all the way to the right side of the 94. This is a second example. You guys see this, it will useful. Guys, let's see about traversal. Traversal is nothing but visiting every element in the binary search tree and accessing them. It is kind of three types. It is in order, pre-order, and post-order. Let's see what are they. Let's see what are those three traversal techniques. It is of pre-order, in-order, and post-order, right? Traversal is nothing but accessing every element. But in these three kinds, we are accessing the elements in different ways. That's it. So pre-order means first we are accessing the node value, then the left, then the right subtree. In order, we will accessing first the left one, then the node value, then the right subtree. In post order, we are accessing first the left subtree, then the left subtree, then the right subtree, then the node value. Like this. It is quite confusing, right? How we can remember like node, left, right, how we can this. So what pre means, we will go for the simple trick. Pre means starting. We will write the node in the start. In means middle. So we will write the node in the middle. Post means node is last. So we are writing the node in the last. So we will always come from left to right, right? Will always come from left to right. So we will write from left, right, and left, right, and left, right. So it is as simple as that. So in exams, we guys have asked to write about in order and pre-order, post-order traversal techniques of elements, how we are implementing. So we will having this simple trick. We can't write like every time we will go node, left, right, and no, left, node, right. It is quite so complicated and so time taking first of all. So I came across with the simple technique. So let's see what's the technique. First, we have to add the dummies for everyone. We are adding the dummies. So it is, we are doing just this one because it is time taking to do this uh, in separately, in order separately, pre-order separately, and post-order separately. We are doing all at the same time. So let's start from the starting. Let's start from here to the left. So how this line is going, we are accessing the elements. So first we have accessed the number 8. So we are writing in the pre-order. Then we are accessing the number 3. So we are writing 3 here. Then we are accessing the number 1 for the first time. Then we are writing here. Then if we come like this, we are accessing the 1 for the second time, right? Second time means in. So we are writing 1 here. Then we will go like this. Then it will we are accessing the 1 for the third time. So it is a post order. Like this we will go like, we are going like this, like he in a hierarchical manner, like see, like this. We will go like this, and like this. If you go all the way like this, if we are accessing the element for the first time, we will write in the pre-order. If we are accessing the element for the second time, we will write in the in order. If we are accessing the element for the third time, we will write in the post order. So let's write rapidly. So we'll go like this. It is for the second time, right? So we'll write 3 here. We will go like this, 6 for the first time, right? First time. So we'll write 6 here, and 4 for the first time also we will write here, and 4 for the second time we will write. 4 for the second time means it is in the in order, and 4 for the third time means it is in the post order. Then 6 for the second time. Second time means in order. 7 for the first time. Then 7 for the second time and the third time. Second time and then the third time. Next, we'll go like this, 6 for the third time. So we'll write the 6 here. And 3 We have accessed it here and here. We are accessing for the third time, right? Third time means where we will write it in, of course, in post order. Then we'll accessing the 8 for the second time. Second time means in, and 10 for the first time. 10 for the first time means pre-order, and 10 for the second time means in order, and 14 for the first time. 14 for the first time, and 13 for the first time. Like this, we will go all the way like this and like this and like this. We'll lastly we will come across, we are accessing the 8 for the third time. We will write the 8 here. Okay, you guys clear about it? So you guys see, pre means we have discussed, right? P means node value first. So here node value first. In means node value middle. Here see node value in between. So post means the node value last. Here we give the node value last. So that's it guys. Traversal is as simple as this. You guys do these examples so you guys can have the clarity about that. Let's see how we can search the element. Searching is so simple. Like we have know about the logic of binary search trees. Like we are having the smaller value, so we will throw it to the left side, and if we are having the larger value, we will go throw it to the right side, right? So we have to search the element 12. So we will start from the root node 45. So 12 is smaller than 45, so it must be in the left side, and 12 is smaller than 39 too. It must be in the left side. So we found the element. Next, we have searched the node 32. So 32 is smaller than 45. It must be in the left side, and 32 is smaller than 39. So it must be on the left side. But 32 is larger than 12, so it must be on the right side, right? And 32 is smaller than 34, so it have to be in the left side. So it is there. We found that element. What if the element is not present? So let's see. So let's 40. 40 is smaller than 45, so it must be on the left side if you are assuming. So 40 is larger than 39. So it must be have to be in the right side, but it is not there. So what we can do now, we can normally we will have to insert the element in there. How we can insert the element? Let's insert 40 first of all. 40 is having in the left side first, then uh, the 40 is greater than 39, so it is having the right side. So let's see here in the pseudocode. First, set the left subtree and right subtree values to the null. If the value of the tree is less than that, insert it into the right side. Else, insert the tree value we are having in this case towards the left side. So that's it to insert the nodes. So if you have to insert the 75, first 75 is greater than 45, it will go like right side. Then it is also greater than 56, it will go right. And 78 is greater than that, right? So it will go left side. So 7 see, in 67. Oh, so 75 is greater than 67. So it have to go towards the right. So that's it, guys. It is of insertion. It is so simple. And let's see the bonus course, deletion. Let's not go very deep into the topic. Let's discuss briefly how we are deleting the nodes. Let's see with this an example how we are deleting the leaf node. In this example, we are having the value 20. So 20 is less than 67, so it is on the left side. 30 it is 20 is also less than 34, so it is on the left side. So let's find that element. Okay. Now we found the element 20. So after founding, we are deleting that element. As like 20, now we are going to delete the node 80. So 80 is greater than 67, right? So it must be on the right side. After finding that element, we are going to delete the node 80. So let's see how we can delete the node which are having the one child. If the parent node which is having child, right? If we delete this node, it will suffer, right? It have feelings too, so it will feel. So what we do is, if you're deleting the node 82, we will connect it to the parent element, that is the grandparent of it, which is root node 67. So now it is having some link, so it will not suffer as much as it is suffering without having any connections. Let's see an example with this 34. 34 is having so much family first of all, right? So if we want to delete this 34, it will suffer, right? So what we do is, we are going to connect this 45 to the grandparent of the 59, which is a root node. So it will not fail, or it is having this link. So let's see. Yes, we connected it. If you are going to delete the grandparent, that means root node. What happens if we deleted that node? The the children of the root node will become the root node then, as like that. Now let's see, if you're having the node value which is 81, it is having two childs, not one child. It is having two childs now. So if we deleted the node 81, we will going to add these left subtree to the node which is deleted. So let's see how. Like this. Okay. uh, if we want, we can also add that element another type also, another kind of type also. Let's see how it is. If we want to delete the 81 we have deleted, in that place we can add another left subtree which is 89 also. So remember guys, if you are going to delete the node which are having two children, just remember the logic. We are going to insert in that place that are nodes which are present on the left subtree. Replace the node which are we deleted, replace that with the left subtrees. It will satisfy the that condition in every single time. Okay. Thank you guys. That's all for today's amazing session. Today we have discussed many topics like binary search trees, creation, traversal, insertion and deletion. Guys, please do like, share and subscribe. Guys, that red color button, please click on it. And let's have some more fun and interesting videos. Thank you. Thank you very much. Bye bye. Stay tuned.